Hey, this video is about parallel analysis in SPSS. So we're going to start with a principal components analysis, or PCA, and we're going to jump down and look at the eigenvalue. So how many factors is it going to want you to retain? In this case, it looks like 4. So eigenvalues above a 1 should be a factor retained. We can see that there's one large eigenvalue and then some smaller ones, and this is even more prominent in the scree plot. So one major one and then 3 little ones. The question here is, are the little ones due to complete chance, or are they real factors that need to be retained? And that's what we need to understand. We can look at the components matrix and get a feel for where they're loading. I will note that in the unrotated, scanning through component 1, you can see everything is above a 0.4, so everything is loading, at least cross-loading, on factors 1 and others. It's really when we get to the rotated components matrix that you see how these other 2, 3, and 4 components start to pull out into their own idea. So parallel analysis is going to allow us to see if these 3 little factors are due to chance, or are they real factors that we need to retain. So for parallel analysis, we're going to use this syntax, and it looks really nasty if you're not used to looking at syntax, but all you need to know is there's 2 places that you need to enter data. How many cases do you have? So in my data set, I had 170 valid cases, and I had 15 variables, 15 items for this, this big idea, this factor. Do all of that, and then we're going to highlight it. So Control All, highlight everything, and we're going to hit this play button right here. So we now have new eigenvalues. Those are the ones right here in the middle. So these eigenvalues, we're going to see which ones compared to the PCA that we are looking at. So what the parallel analysis has done is created a mock data set for what we have. So I have 170 cases with 15 variables. It created random answers for 170 people across 15 variables. So all of this is random data, and it's randomly seeing how this data actually groups together. The idea being that if we have 8, in this case 7, factors that are retained randomly, then my 5, I can compare those two and say, is it a real factor or is it similar to this chance data set? I highly recommend putting it all into a new side-by-side comparison of eigenvalues. It makes it so much easier. These are just made up. They're not the exact numbers, so don't try to compare. But in the parallel analysis here, we have retained 6 factors. So the random chance says 6 factors. In our data set, it says 4 factors. So the question is, are these 4 factors real factors, or are they based on chance? So we're going to see which one's bigger. That one in the PCA is larger than the parallel analysis. This one is larger than the parallel analysis, and here's where we start to get into chance. So this 3rd factor is smaller, the eigenvalue is smaller than the parallel analysis. So this factor should not be retained because it is due to chance. I am instead going to retain 2 factors for this exploratory factor analysis. Now, the PCA that you just ran said 4 factors. We want to go back and we want to force it into 2 factors. That way we can re-examine how everything fits together. So I'm just going to go back to factor analysis and extraction. So instead of having it being based on eigenvalues greater than 1, I'm going to force 2 factors, hit continue, run everything the same, and you will notice that it's still saying that there should be 4 right here, and we're still seeing the same scree plot. What has changed though is the component matrix is forcing everything to fall into 2 different categories, 2 different factors. So we're going to look at the rotated components matrix, and now we're going to look at those the items that fall above a 0.4, and we're going to really look at how those are working. This one's cross-loaded, that's a problem. But now you can actually go ahead and start your problem solving.